Lesson 9-4 for 6th grade math, adding integers.
If you add integers, how can you predict if the sum will be positive or negative? For example, 3 plus negative 5. In this lesson, you will learn to add integers by using integer chips. Let's review. Integers can be modeled with integer chips. Yellow chips represent positive numbers and red chips represent negative numbers. A zero pair is made when opposite quantities have a sum of 0. Here we have the opposites positive 1 and negative 1. You can think of the opposites as canceling each other out. 1 and negative 1 are a zero pair. A common misunderstanding is to think that more chips always represents a larger value. In the example below, we have 4 red negative chips and 3 yellow positive chips. We might think that negative 4 is greater than positive 3 because there are more red chips. However, we must remember that as we move to the right on the number line, the numbers increase. Since 3 is to the right of 4, we know that negative 4 is less than 3. Let's look at when we add numbers with the same sign. We have 4 plus 2, 4 positive chips and 2 positive chips. Together, we have 6 positive chips. If you add 2 positive numbers, the sum will always be positive. This makes sense because you only have positive chips. Now let's add 2 negative numbers, negative 3 plus negative 2. We have 3 negative chips and 2 negative chips. Together, we have 5 negative chips. If you add 2 negative numbers, the sum will always be negative. Again, this makes sense because you're just adding more negative chips. What happens when the signs are different? Like 4 plus negative 2. We have 4 positive chips and 2 negative chips. When we combine them, we see that we have 2 zero pairs and a remaining value of positive 2. So 4 plus negative 2 equals 2. Let's look at another example, negative 5 plus 4. We have 5 negative chips and 4 positive chips. When we combine them, we have 4 zero pairs and 1 negative chip left. Negative 5 plus 4 equals negative 1. Did you see a pattern when we added numbers with opposite signs? After you make zero pairs, the sum will have the same sign as the number with more chips. In the first example, there were more positive chips, so the sum was positive. In the second example, there were more negative chips, so we had a negative sum. Let's review what we've learned. When we add numbers with the same sign, we add the two numbers together. The sum will have the same sign as the addends. When we add numbers with different signs, we make zero pairs. The sum will have the same sign as the number with more chips. In this lesson, you have learned to add integers by using integer chips.
Welcome to a lesson on adding integers using the number line. Let's first review what integers are. Integers are the numbers that can be written without a fractional or decimal component, and they fall within this given set here. In order to add integers using a number line, if a number is positive, we'll move to the right on the number line, and if a number is negative, we'll move left on the number line. And that should be pretty logical because the positive integers are on the right side of the number line, and the negative integers are on the left side of the number line. So even though we know 2 plus 5 is equal to 7, let's go ahead and model this on the number line. We would start at 0 and move 2 units to the right because this is a positive 2. And then since we're adding positive 5, we'll move 5 more units to the right. which results in a sum of 7. Let's take a look at some additional examples. Here we have 5 plus negative 7. So we'll start at 0 and move 5 units to the right because this 5 is positive. And now from here, because we're adding negative 7, we're going to move left 7 units. So if we move back 5 units, we're back at 0. We're going to move 2 more units to the left. So this sum is equal to negative 2. Again, this was the movement from the positive 5, and this was the movement from the negative 7. Here we have negative 2 plus 6. So for the negative 2, we'll start at 0 and move to the left 2 units. And then from the negative 2, we're going to move right 6 units because this is positive 6. So from here, move 6 units to the right. 1, 2, 3, 4, 5, and 6. So our sum will be positive 4. Let's take a look at a couple more examples. Here we have negative 3 plus negative 5. So again, we start at 0. We'll move left 3 units for the negative 3. And now we're going to add negative 5, so we're going to move 5 more units to the left. And we're going to end up at negative 8. So negative 3 plus negative 5 is equal to negative 8. Now in this last example, we probably already know the sum is equal to 6. But to model this on the number line, we would start at 0, move to the right 2 units, and then move to the right 4 more units. So our sum would be positive 6. Okay, so that's how you can use a number line to add integers. I also have 2 other videos that show you how to use what I call the money analogy, and another one that shows more formal rules for adding integers. I hope you found this helpful. Welcome back to another video on adding integers. This video uses the formal rules for adding integers. I do have other videos that show other techniques for adding integers. Let's first start off by reviewing what an integer is. Integers are the numbers that can be written without a fractional or decimal component, and they fall within the set listed here. So let's go over the formal rules for adding integers. When adding 2 integers, it'll fall into one of 2 conditions. Either we're adding 2 integers with the same sign, or we're adding 2 integers with different signs. If we're adding integers with the same sign, we add the absolute values of the numbers and then keep the sign of the original integers. However, if we're adding 2 integers with different signs, we take the absolute value of both, we subtract the smaller value from the larger value, and then the sign of the answer is the original sign of the number with the larger absolute value. So let's go ahead and see how this works out. So for example number 1, we have negative 5 plus 6, so we have 2 integers with different signs. So we take their absolute value. The absolute value of negative 5 would be 5. The absolute value of 6 would be 6. And because they have different signs, we subtract the smaller from the larger. Well, 6 minus 5 would be 1. And then to determine the sign of the sum, we take the sign of the number that had the larger absolute value. If 6 had the larger absolute value, 6 is positive, so the sum is positive. On number 2, we have 2 integers with the same sign. They're both negative. So the formal rules say take the absolute value of both. That would be 8 and 3. And because they have the same sign, we add them this time. That would be 11. But then we keep the sign of the original numbers. So instead of positive 11, it will be negative 11. So the big difference here is the 2 integers have different signs. We subtract the smaller from the larger, after we take their absolute values. And if they're the same, we find the sum after we determine the absolute values. So in number 3, we have different signs. One's positive, one's negative. So we take the absolute value of both and then subtract the smaller from the larger. So the absolute value of 1 is 1. The absolute value of negative 7 is 7. We subtract because the original sum had different signs. Well, 7 minus 1 is 6. However, since the 7 was the larger number and its original sign was negative, our sum will be negative 6. Let's try a few more. Negative 25 plus 63. One's negative and one's positive. So once we find the absolute values, we'll have to subtract. The absolute value of negative 25 would be 25. The absolute value of 63 is 63. Notice how I always write the larger number on top, because I know since they have different signs, I will have to subtract. So borrow. 13 minus 5 would be 8. 5 minus 2 would be 3. So our sum will be 38. And it will be positive 38 because 63 is the bigger number, and it's positive. Number 2, we have negative 31 plus negative 84. Again, we'll take the absolute value of both, which would be 31 and 84. But since they have the same sign, we'll add them this time. So we have 5 and 11, 115. And since both integers were negative, our sum will be negative 115. In the last example, again, we have two integers with different signs. So we'll take their absolute values and then subtract. The absolute value of 15 is 15. The absolute value of negative 47 is 47. Again, notice I always get in the habit of writing the larger number first, just in case we do have to subtract, like we do here, because they have different signs. So we subtract. 7 minus 5 is 2. 4 minus 1 is 3. So our sum is 32, but since the 47 had the larger absolute value, and the 47 is negative, our sum is negative. Okay, so that's how you can add integers using the formal rules, but